So welcome to my channel, and today I am going to discuss SC, BCC and FCC. SC stands for simple cubic, BCC stands for body centered cubic, and FCC stands for face centered cubic. This is the unit cell of a cubic crystal structure. Basically, what is the unit cell? First of all, let me explain. Unit cell is nothing else, it is the basic building block. Say for example, we have aluminum. It has Fcc crystal structure. How we get to know aluminum has a Fcc crystal structure? We have to find out the unit cell with the help of X-ray diffraction, and this unit cell is Fcc in nature. Then we say that aluminum has a Fcc crystal structure. So let us discuss one by one. This is belongs to the cubic known as simple cubic. Let us draw how the simple cubic looks like. This is the simple cubic, where corner of this cubic is the lattice point. Basically, there are 8 corners. At each corner there are a lattice point. We can simply say it is the lattice point, and at this lattice point we simply substitute a atom. At every lattice point we generally substitute an atom. So suppose that if we substitute the iron atom here at every corner, or if you want to place any other atom at the corner, then this is the main motive of this lattice point. So it is the simple cubic. The second one is BCC. BCC stands for body centered cubic. Let us see how it is look like. First we'll draw the cubic system. This is perhaps look like a cubic. My drawing is not up to the mark, but let me correct it. So this, I think we have to erase once again. Let me draw once again. How body centered cubic it looks like. This is a simple cubic. Here is the body centered. It means there are 8 corners and there are 8 lattice points, and due to its body centered, and in the body center, right to the body center, there are one other lattice point. So there are 8 corners and one point as right of the center, and this is known as Bcc crystal structure of the cubic system. So I would like to introduce some example of BCC. First example is iron, Fe, at low temperature. Iron is what? Bcc crystal structure. So simply, eight corner at eight corner there are iron atom, and also that body centered, also the iron atom. Other example of this body centered are, there are a lot of example. We can take a lot of example of this body centered, but basic idea is what? Body centered cubic, simply there are eight corners and there is a one atoms or one lattice point at the right of the center. So moving forward to the next one, it is known as FCC crystal structure. FCC means face centered this is simply is what? Face centered. This is not a crystal, this is cubic. So how it is look like, let me draw the diagram of it. So first of all we make a cubic as similar to earlier one, and by its name it is face centered. That means, as we know, there are eight corner and hence there are eight lattice point. And due to its name of face centered, there are how many faces? There are six faces, and each faces, each center of faces, there are one additional lattice point of these faces. The center is here. We situate a lattice point here. One is here for these faces. One is here for these faces. One is here for these faces, and there are also the two faces. This one and backside this one. So you also substitute two lattice point. So how many lattice point? 1 2 3 4 5 6 7 8 and 6 are there. 40 lattice point. At each lattice point represent a atom position. If we suppose that we take example of this type of FCC system, like aluminum has FCC crystal structure, copper has Fcc crystal structure, nickel has Fcc crystal structure, steel, plain carbon steel has Fcc crystal structure. So let me other example. Gold has Fcc crystal structure, silver has Fcc crystal structure, platinum have Fcc crystal structure. All are the Fcc crystal structure, and it is similar to that. So now there are a lot of other properties. This is the basic one. There are a lot of other properties of this simple cubic, body centered cubic and face centered cubic, like how many, what is the packing density, number of atom in each unit cell, if we're talking about the mechanical properties, how mechanical properties depend on this unit cell, because this is the viewpoint basic viewpoint of designing a material. Suppose that if you design any material, we have to understand what is the nature of that material. So we have to know what are the crystal structure. For as for sake of knowledge, this is a very lower ductility. FCC has very higher ductility. Why it is so? I have to explain in next video. Thank you very much.